All right, this is Chapter 7, Periodic Properties. This chapter is all about the periodic table. Make sure you have a notebook and a pencil and your periodic table handy, as we're going to write a number of things right on the periodic table throughout this unit as well. So the development of the periodic tables happened in the mid to late 1800s. Dmitri Mendeleev and Lothar Meyer from Germany both submitted journal articles at that time that indicated that they started to organize the elements that were known. And if you want to take a look on your digital textbook, this happens to be the 13th edition of Brown-LeMay, you can notice the limited number of elements that were known in ancient times are in this like dark gray color, and then a lot of elements weren't really discovered or isolated until the 17 and 1800s, and even some not until the 1900s. So the organization was first noticed or recognized by these two and others by the similar patterns of their reactivity and how they acted. So species like lithium, sodium, potassium, rubidium, and cesium were known to all react with water, and that was one of the similar patterns that made them be in the same group or family. And originally, when they went left to right, top to bottom, they ordered them by atomic mass or atomic weight. Henry Moseley came along in 1913, and he x-rayed a bunch of elements, and he found out that they ended up with unique, they gave off a unique frequency when they were blasted with x-rays. And this then allowed him to start to assign atomic numbers or organize the periodic table by atomic number, and that leads us to the periodic table that we have today, which is organized by atomic number 1, 2, 3, 4, 5, 6. So let's finish this first video just by going to the periodic table and making sure that you have some pieces on the periodic table that I think most of you already have. First of all, make sure that you have this stair step put in there, because that's one of the pieces that identifies areas of the periodic table, knowing that this area over here on this side then is mostly the nonmetals, except for hydrogen, which also fits in here as a nonmetal. In this area to the left of the periodic table and down, these are all metals on the periodic table, including these guys down here. These, of course, are the S group, which you learned in last chapter. These are the P group, or the P block, this area right here. This is the D block right here, so the orbitals filling in the D sublevels. And remember, the D sublevels are always one number, one principal quantum number less. So it would be the 3D block right here. The 5 would actually be the 4D block. And then these guys right here, the lanthanide and actinide series, actually fit right in here in these boxes. And the expanded periodic table would actually have it split right here, and these would actually form another little bridge separating everything. These are also metals down here, and were some of the last elements identified in the 1965s or later. Other pieces that you should know are the names of the groups or families. So these, of course, are the alkali metals. These are the alkali earth metals. These over here are called the halogens, and these, of course, are the noble gases. And then there's a number of other pieces that you probably already know. Let's just go through them really quick. These typically form +1 ions because you lose one electron. These typically form +2. These typically form +3. These, as we've seen before, are kind of a mess, plus or minus, sometimes 2, sometimes 4. Typically these form -3, but they can also form other ions, especially in here in the phosphorus-sulfur area, generally -2, -1, and the noble gases, of course, are very non-reactive. Interesting to note that the noble gas configuration is preferred by all elements, but helium or hydrogen wants to become a helium, and so hydrogen's configuration is 1s. Helium, of course, is 1s2, and so a lot of people say, well, all elements on the periodic table want to obey the octet rule. Well, that's not necessarily true. The duet rule is a real important one for hydrogen. And lithium, of course, if it could lose an electron, normally is 1s2, 2s1. If it could lose an electron, it would also obey the duet rule and end up looking like helium. So maybe a better thing to say than the octet rule or the duet rule is to say the noble gas rule. most species want to eventually obtain a noble gas configuration. So in the rest of this chapter, we'll take a deep dive into the periodic table of the elements, and we'll look at lots of trends and lots of regularity, repeating patterns throughout the periodic table. We'll classify those, we'll put equations to them, and we'll describe a lot of how the periodic table helps us describe matter here on Earth.